Welcome to AASHTO Resource Q&A. We're taking time to discuss construction materials testing and inspection with people in the know. From exploring testing problems and solutions to laboratory best practices and quality management, we're covering topics important to you. Now, here's our host, Brian Johnson.
Welcome to AASHTO Resource Q&A. I'm Brian Johnson, and today we are going to talk about something I've been hearing about for the last few years in the construction materials industry, especially with the DOTs, and that is balanced mix design. With me today to talk about it is Brian Pfeifer, Engineer of Materials with the Illinois Department of Transportation. Welcome, Brian.
Thanks.
And Brian Hill, Hot Mix Asphalt and Aggregate Engineer, also with the Illinois DOT. Welcome, Brian.
Thank you.
If you're counting, that is 3 Brians today on the episode and no Kims. So Kim couldn't join us today to be the co-host, but she will be producing this, which means that anything I say that is embarrassing will be included in the episode. And anything I say that sounds remotely intelligent will be cut, as she often does. So we'll get into this, though. Let's start with Brian Pfeifer. What is balanced mix design for those who have never heard of it?
Okay, so for asphalt pavements, we're looking to find a balance in performance primarily between rutting and cracking. So we're trying to optimize our performance. And for us, it means to try to balance our use of recycled materials as well and make sure that those recycled materials are used in a way that doesn't have a negative impact on performance, that it's, we're getting the performance we're looking for and expecting. I think that's an important part, I think, when it comes to sustainability, to keep in mind that you may be adding a material or using a material that is appearing to make a mixture more sustainable. But if you don't get the longevity, if you don't get the durability or the out of it, then you're not realizing that improvement on sustainability. So it's really about balancing between those two ends of performance.
Now, Brian Hill, do you have anything else to add to that?
The only thing that I would add is that we also include a moisture resistance test in Illinois Modified AASHTO T283, just to make sure that we're considering moisture as well.
Okay, so I heard, in addition to the moisture, sustainability, performance, longevity. I didn't hear anything about volumetrics, which used to be the target, right, for people when they were putting a mix design together. What happened to volumetrics?
Still definitely there. And in Illinois, for our larger projects, we have a percent within limits specification with incentives and disincentives. So that's definitely still there and important, and it's still a big issue.
Okay, that's something I was wondering about, because in all these discussions, I was wondering if the term balanced mix design was a change in strategy for developing mix designs for state highways and interstate highways, or if it was just another term that is used. Like, I didn't know if it represented a significant change to what you do, or is it just a progression of what you were already working on?
Yeah, I guess I'd kind of think of it more as a progression, and it makes me wonder if I'd never really thought about that terminology before in that way, that it's focused on mixed designs, but really it's the mixture that we're trying to balance performance with.
As far as recycled materials are concerned, have you increased the percentage of recycled asphalt pavement that is going into the mixes in Illinois?
We have, and actually that was what kind of prompted the research originally back in around 2013 or so. There were some increases made to the amount of RAP and RAS as well, the reclaimed asphalt shingles. And so in looking at our performance and kind of seeing some indications of some premature cracking, that was a reaction that we had to, and we'd already implemented the Hamburg wheel on the rutting side of performance a few years before that, or a year before that, in 2012. So it really made us take a look at the cracking side of things by, looking at the premature cracking. And we saw that as potentially related to those increases in recycled materials. And then since we've implemented, and as part of our implementation effort in collaborating with industry, we agreed to increase our recycled binder content by 5% on all of our mixes. That was, so now that we have those performance tests, we know that when recycled materials are used, then they're going to be still meeting our performance criteria. Then we feel more comfortable raising those limits.
So as you raise those limits, do you have to make any other adjustments to account for that to make sure that you can avoid cracking? Brian Hill, you want to take that one?
What we do in Illinois is at 20%, we have a grade bump down one grade, both on the high temperature grade as well as the low temperature grade. So for example, if a mixed design had more than 25% or had 25% ABR and the contract plans called for a PG 6422, that contractor would need to use a PG 58 minus 28 to adjust for the asphalt binder that's replaced.
Okay, so for those of you who are not familiar with asphalt specifications, Brian's talking about performance graded binder specifications, which is the liquid asphalt that goes into the mix. So it's not necessarily that you're adding more liquid asphalt, it's that you're changing the grade, or are you also increasing the percentage of virgin asphalt binder that goes into the mix?
That's not a requirement to increase the amount of virgin asphalt binder. That's more of a function of the process of meeting volumetrics as well as the balanced mix design criteria. So that'll be a function of the contractor's decisions with regard to the different materials that they use.
I was wondering, the DOT doesn't specify what the design or what the ingredients and percentages have to be, right? The contractor can determine what what they feel is the optimal mix to provide the sustainability and the resilience you're looking for.
Right. It's the contractor's responsibility to design the mix and to optimize based on their material sources, based on their plant operations, and to determine the most economical mix while still meeting those volumetric criteria and performance criteria now too. So the performance criteria is kind of added on. I mean, we had done the TSR, the moisture sensitivity prior to this, but yeah, so it's kind of a little bit of extra to ensure performance.
Okay, so we've got more parameters that the contractor has to be concerned with, right? To avoid the cracking and the rutting problem. So let's talk about those. So it sounds like there's some other tests that people have to worry about. You mentioned the Hamburg. What else is Illinois using to evaluate cracking?
So for cracking, we're using the Illinois Flexibility Index test. And so that was something that came out of that early research. So in 2013, when we were looking at the amount of recycled material we were using and the brittleness of our mixes and the potential and propensity for premature cracking, then we worked with the Illinois Center for Transportation at the University of Illinois that they handle our contract research program. And so worked with Professor Alcati over at ICT and started a research project to take a look at the options out there and what type of, I think at that point, there were a lot of questions, a handful of cracking tests that people were looking at, but no one was really sure what kind of direction to take. So the University of Illinois, through that research, had kind of used the semicircular bend test as a kind of a starting point and kind of evolved with that philosophy and helped us to develop that Illinois Flexibility Index test. And then help us also then to develop the criteria.
So Brian Hill, do you regularly perform they also call that the iFit test, right? That Illinois Flexibility Index test. Do you perform that or does your laboratory perform that at the DOT?
So in the process of getting going with iFit evaluations, Central Bureau of Materials purchased devices for the district laboratories. So we have 9 districts within the state of Illinois. And so the district laboratories handle the day-to-day operational tests with regard to iFit and Hamburg in terms of mixed design and production.
Can you take us through that test a little bit just so that our listeners can understand what happens during that testing?
Sure. So the Illinois Flexibility Index test is completed at approximately 25 degrees Celsius. There is a temperature range, but at approximately 25 degrees Celsius, as Brian mentioned, it's a semicircular bend geometry. There is a notch that is placed in the specimen to initiate a crack at the end of that notch and such that it travels through the remainder of the ligament. The test is completed at approximately 50 millimeters per minute, or 2 inches per minute. And then at the end of the test, the load versus displacement curve is produced. The area under that curve is integrated, and then we look at the post-peak slope at the inflection point of that post-peak slope such that we can calculate the flexibility index parameter.
so people can understand what this looks like. Imagine an asphalt core that is sliced in half, where you've got a semicircle instead of the entire core circular shape. And there's a notch cut in it. So you can imagine what that looks like. So you've got a semicircle with just a notch in it, and it's on a frame that has supports on the outside part away from the notch, it with a point load above the center. So it's kind of pushing down on that notch. And that's where you get does it typically fracture all the way through, or does it stop when it starts to fail?
By the time you get to 0.1 kilonewtons remaining, the test is finished. And so more than likely, it won't go all the way through. Otherwise, you get unstable crack growth and the device would actually stop itself. And we also have end plates on our devices in particular. So if you did have unstable crack growth, you may reach a point where they would hit the end plates and then you'd actually have the load ramp back up because of the response.
Okay. Now, other than the index, is there any sort of subjective determination of how the cracking occurred in this test that tells you anything?
I mean, you can look at it visually and see whether or not there's more failure with regard to the mastic or whether it's more at the interface with the aggregate particles. You can also look at, especially short-term age versus long-term aged specimens in general, the more tortuous a crack is, the more cracking resistance that particular sample or that particular mixture has. If it is a very straight crack without very much tortuosity, then in reality, that means that that crack is very quick to form. And so therefore that mixture is relatively brittle.
Typically, when you test these specimens, is this all done before the material is laid down, or do you run this on cores that were taken from the edge of the roadway?
We test both in mix design and production, but it's from loose mix that is compacted. As part of research studies and as part of some of our pilot project work that we've completed, we do test cores. So, I mean, that is part of more of the research process, but not as part of the determination of whether someone is going to continue using that mix design or whether that mix design is going to go forward for use.
Have you done any of this testing on failed roadway cores? What's that process like if you have?
We have. I mean, I can't say that we've looked at a large number of roadways that have necessarily used the term failed. It's primarily looked at indications of both pavements that are early in their service life, as well as with regard to research, looking at some that have performed poorly, some that are more in a moderate sense, and some that are in a better category. I think that larger effort, and Brian Pfeifer, you can verify this, but the initial IFIT research study looked at pavements that were in good, moderate, and poor performance to evaluate and determine some level of metric with regard to where flexibility index would be.
Right. Yeah. We had at one point asked all 9 districts to submit cores from roadways that in relation to cracking good performing pavements versus what they would consider poorly performing. So at that point, it was just kind of a rough. I mean, later on, when we were actually correlating the IFIT results in the lab to performance in the field, that was done where transverse crack length was measured, over years, and cores were taken then. But you do have to be careful about comparing the results you get from testing a core as compared to the loose mix. So those aren't the same numbers, or they don't mean the same thing. So, and I think, Brian, you could maybe explain a little bit more about that.
As part of the 2016 pilot projects that the department completed, there were 11 total projects. And so testing was conducted generally on mixed design, production, and annual field cores that were evaluated, including post-construction field cores, so immediately after construction. And as part of that process, it was identified that there is a difference between loose mix versus field compacted specimens.
Yeah, and I do want to point out I use the term failed, and that's not really the right way to look at it, because there's, exhibited cracking is probably what I should have said, because it's not like the road just disintegrates or collapses. It, there are varying degrees. There could be small cracks, there could be bigger cracks, different types of cracks. When you drive around as a traveling public, you're going to see cracks on roadways, right? And there are ones that you can think, oh, well, that's normal. And there's ones you can say, well, that looks like a concern. How do you know the difference between normal and a concern?
In relation to this subject, to correlate field performance with what the IFIT, the flexibility index, is showing us, we would look at transverse crack length. And in Illinois, we've got a lot of our original pavements were built from concrete, jointed concrete. So the transverse cracks are the cracks that reflect through that were in that concrete pavement and reflecting through the asphalt. And then eventually, yeah, like you said, they start out, where your hairline, you can barely see them, and really doesn't get to be a problem for the public until it's actually starting to come apart. And I think this is common across a lot of DOTs now, and focusing more on the preservation side of things and trying to have some treatments to be able to prevent that, to treat the roadways before those cracks develop to that degree where they're causing problems, opening up into potholes or causing a lot of roughness. It is a convenient way for us to monitor performance and to correlate field performance with the test results.
That's also a good point, is that once you start seeing cracks that the DOT considers to be unacceptable by their terms, then they do have pavement preservation techniques that they can employ, crack sealants and other ways to stabilize that roadway or smooth out or improve the rideability and performance of that roadway without having to rip it out and rebuild. Let me ask you something else about the balanced mix design. So the reason why I reached out to you to talk about this is Illinois is considered to be 100% implementing the balanced mix design. And you already talked about what that means, but how long will it be before you have a good handle on this and feel like, hey, this was the right thing to do? We're seeing improved performance. We're happy with this. We can report back to the other DOTs and the Federal Highway Administration and say, hey, we've got something good here and we're proud of it.
We've had a lot of success already. I think prior to implementation, we were really comfortable with that tie between field performance and test results. So we feel like we're getting better cracking resistance. We didn't really have a rutting problem, but we kind of knew that already. But that was because we had the Hamburg wheel test already implemented in 2012. So throughout this process, we've been throughout implementation. It's taken quite a while, quite a few years, but it's been a very deliberate process where we've worked closely with our districts. Brian had mentioned earlier, getting the equipment for all 9 districts, getting them experience with testing. We've also collaborated closely with our industry partners too, and had a task force set up to talk about implementation along the way. There were a number of progressive contractors who got their own equipment, started doing testing, characterizing all of their mixes to see where they stood. And so yeah, and then that correlation with field performance and the pilot projects that we've really, I think, progressed a long ways through research and through collaboration already. So as far as proving it with field performance over a long period of time, that's going to take a number of years, I think. Actually, just now implementing a pavement management system that is really going to help us closely track performance. But in field performance, you really have to take a really close look. There are a lot of things that can happen with a pavement, and it could be the underlying material. It could, be different circumstances of the mix and placement, compaction, a lot of things that can go wrong, and, a lot of things that need to go right to get the performance, that we see here. So I think overall things go very well, and we see very good performance in our pavements in Illinois. And we saw that before. It's just we've raised the bar even higher, I think, with this effort. So, but yeah, I think in the years to come, we'll get more firm data, I think, on that, in looking at our pavement management data. But I think we have had a lot of success so far.
Yeah, now you mentioned the partnering with private industry. With the development of this strategy or the implementation of the additional tests and specifications around rutting and cracking, is this something that the industry kind of moved together with you?
I think we were ready to go and ready to implement a little bit faster than industry. They did I think it was in 2020, January, that we were planning to implement, and industry did ask for an extra year for shadowing. And I think I mentioned earlier that there were a number of contractors who really invested and they bought into it. They kind of realized this was the direction that we were headed, and they were in agreement with that direction, I think. And so they did a lot of work, and they even shared, it's a competitive industry, but and they didn't openly share all their data with their competitors or with their industry, but they did share data that kind of redacted data that showed. And that's something too that we did, I think, that helped the implementation effort. And Brian can speak to this more. There was a database that was developed that was all the district data, all of our central materials data, and all the contractors data. And I don't know how many data sets we're up to now, but it's in the thousands.
Yeah, we have comfortably over 4,000 test sets. There are multiple replicates per test set.
That's a lot of data.
And we've held workshops. We've got a Illinois Bituminous Paving Conference that's hosted at the University of Illinois annually. And so we've had workshops, I think at least 1 year, maybe if not 2 years. And the contractors have presented their data, along with ours. And I think it's really been a partnership throughout this.
Yeah. Now, one way that states have encouraged the implementation of new technologies or strategies has been through incentives or warranties on roads, or some kind of way that the contractor is incentivized to produce a more stable or long-lasting roadway. Does Illinois do anything like that?
We have incentives on the volumetric parameters, and so for density, that covers 40% of the incentive, and then voids and VMA are the other two components, each at 30%. So we pay up to 105%. And then also there's a disincentive side of that too. But really, in analyzing that data, I know that for the past few years, we've been kind of reporting back to industry on where things stand, and we're paying a fair amount in incentives, but we also realize we're getting a performance enhancement out of that. Especially, we know that the density of the pavement is really a huge key and correlates directly. There are studies that have shown strong correlation between in-place density and performance. So, we feel like we're paying those incentives, but we're also getting a performance advantage in return. So at this point, it's just on the volumetrics that we pay incentives and also assess disincentives. We haven't had any kind of discussions yet on any incentives or disincentives for performance testing. There'd definitely be some challenges. We don't have the frequency of testing that we would need, and that would be a challenge for us to have the resources to do that.
It's a lot easier to go out there with a nuclear density gauge and get a lot of test points on density compared to taking a core, preparing it for the rutting and the cracking testing. I mean, that's a lot of
clarification on density. We do use cores for our density. We feel like that's a more accurate measure of in-place densities. It does leave a hole in the road, but it's a pretty straightforward test to run as opposed to the performance tests.
Those district labs, I mean, how much time are they spending on these performance tests compared to some of the other tests that they're doing?
I think they're still completing more in terms of volumetrics than they are with performance tests. I mean, performance tests do take up a considerable amount of time, but with the testing intervals that we have for our different quality management programs, volumetrics still require more time in generality.
But for the performance tests, we're just running those during mix design and then once during production. And really those for projects over 3,000 tons, we would just take performance test samples at the beginning of the job. Whereas our volumetrics, those are being done, samples are being taken throughout production.
Brian, you're also the aggregate engineer. What kind of aggregate tests are you having the districts work on in addition to the hot mix tests?
Districts conduct gradation testing. Quality testing is completed in the Central Bureau of Materials.
What are they doing? Extractions or ignition and gradations to see what's in the mix?
Oh, in terms of the extracted material, yeah, I mean, they're still conducting gradations there. We use either ignition oven or extraction according to Illinois Modified T164. We also allow asphalt content to be determined by nuclear method, which then wouldn't have that extracted gradation.
Oh, really? You mentioned for the balanced mix design, you're using an Illinois practice. or specification for how you handle this? Is there an AASHTO standard on the practice of developing a balanced mix design strategy at the DOT? Is there like an M or an R standard that explains how you handle this?
Yeah, there's a provisional standard, and I don't recall the number, but it's actually got a summary of the state DOT the current practices, just because there are a lot of still quite a few different cracking tests and different rutting tests. That's something that being updated as we speak through this round of updates for the material standards. So it's going to be continually updated for a while, I would imagine.
Yeah, I think so. Hopefully, we can eventually get to the point where we've got a single rutting test that people are satisfied with and a single cracking test that people are satisfied with, because I think it may not be a big deal where the contractors are kind of working in the one state all the time. But if you're working with multiple states, you really don't want to be in a situation where you're dealing with multiple testing protocols and different pieces of equipment, especially if you're looking at one state is saying, okay, you have to use this particular test and this equipment, and then you have to use this whole other suite in this other state that you border. That would be pretty difficult. So it'd be nice if we could come to some conclusion collectively in the states to say we really like this rutting test and we really like this cracking test. But I don't know if that'll ever happen.
Yeah, we may end up being the outlier there, actually. As I know with IFIT, we're heavily invested in it, and but it seems like for other states, the predominant ideal CT is what's being commonly used. I guess not many of them have actually implemented that, but that's what they're looking to implement. But we've definitely invested heavily and have those field performance correlations established with IFIT, and very comfortable with the test method and what it tells us, what we learned from it. And so we'd have a hard time, moving from that. But yeah, I think Hamburg wheel is probably the predominant rutting test, but there's also the ideal RT that folks are looking at, and Hamburg wheel to try to run that test on a frequent basis, like during production, that would be a challenge. So yeah, it's hard to say. It's definitely an evolving field.
And just last week at the Committee on Materials and Pavements meeting, we heard about another rutting test that people are looking at. There are always going to be new ones coming up because somebody learned something new. So let me ask you this. What can AASHTO do to help Illinois DOT get more data or promote the use of this strategy in Illinois and beyond?
Well, I think actually I've heard something just here in the last few weeks about the creation of a proficiency sample program for Hamburg wheel. That's something that we do within Illinois. We have round robin programs we've had for Hamburg wheel since probably around that 2012 timeframe. And then for IFIT, we started a round robin program in, say, maybe around 2015 or so. And that includes a number of contractor labs. All the districts are participating in that, as well. So, and that was actually how the precision statement was developed for T393, right? We worked with AASHTO and using our round robin data to establish that.
I think we started IFIT uniformity studies in 2017. But in terms of the precision limits, that was developed, I believe, with 2017 through 2019 data. So 3 different years worth of interlaboratory study work. Currently, as of last year, we had 29 participants in our IFIT round robin and 32 participants in our Hamburg round robin. But in terms of analyzing the data, it was just following the ASTM standard with regard to developing that precision statement, knowing that, bias is not really a possible statement that can be created for asphalt mixture since there's no accepted baseline number.
So when we implement this proficiency sample on Hamburg, and I think we'll probably have to have one on a cracking test as well at some point, it's good to know that you already have that many participants. So you've got a sound population of laboratories for statistical analysis, and you can draw some conclusions from that. That would be encouraging for our program to know that at least in your state, there are enough participants. So if that's the case, it can be assumed that throughout the US and really throughout the world that we should have enough laboratories to participate in that program and come up with some reasonable data for providing ratings for people. What I would like to do is hopefully be able to compare some of these methods through the collection of that data maybe we can see how they compare. And if they're comparable, then that's great. And people can use what they want and you don't have to pick. Is there anything else you want to tell people about balanced mix design that we didn't cover today?
If I can, just kind of acknowledge some contributions. We've had a number of folks retire in the last several years who have been heavily involved. Dave Lippert, Matt Mueller, and Jim Trepanier all retired in the last several years and were really instrumental and heavily involved with the evolution of this. I think Dave Lippert talked at a number of conferences here in Illinois before balanced mix design was really a commonly used term. He was talking about Goldilocks analogy for asphalt mixes between rutting and cracking. So definitely some progressive thinkers there. And then also still working for us here, Tom Zaire has contributed a lot over the years to that. He was actually our statewide Illinois DOT Engineer of the Year several years back for his efforts in this area. And then also, I can't say enough about the contributions from the Illinois Center for Transportation and Professor Alcati and his team there. They were a huge help to us and really instrumental, not only on the, you think of universities being involved with more of the theoretical or the research or the laboratory based, but they really did a lot of work to help us tie the field performance to the laboratory test too. So with a study that I think included 8 different pavement sections in the Chicago area and analyzing those, I think they focused in on 5 to correlate with that transverse cracking and field performance. It's been a great partnership for us, and they've really helped us turn research into a very practical and implementable set of results. So appreciate all the work that they've done. And I think we talked too about our collaboration with the industry definitely is a huge part of our ability to move forward with this and with our districts too. So a lot of folks had to come together to, and we've also incorporated these performance tests into our training program too. We worked with Lakeland College here in Illinois for our quality management training program. So for the new technicians, coming into the industry, they're learning about these performance tests and doing that through that training program. So we appreciate their efforts too. That's a big part of it as well. So. And I wanted to acknowledge the Federal Highway Administration too, and the assistance we've gotten from them. And then also we've been working with them really closely the last few years. They've published a few reports or sponsored some efforts. We were the subject of a virtual site visit along with a number of other states. There's a report published through the University of Nevada, Reno in 2020 that highlighted us and several other states. And then we've been working with Federal Highway and hosted a regional peer exchange here earlier this year, and then we're going to be hosting another one here in December. So we appreciate our federal partners and the collaboration there.
Now, Brian Hill, is there anything that you would say to your peers at other DOTs that have not implemented balanced mix design? Any tips or any recommendations you have for them or words of encouragement to move in this direction?
I guess I would just simply say that you feel like there's a benefit to it. We feel like we've gotten more to a quote unquote balanced state with regard to cracking, rutting, and moisture resistance. It does take a lot of time. It does take a lot of effort, but if anybody has any questions, by all means, we're always open. If somebody wants to reach out and ask, or to see how we've set up a database for cracking resistance, or how we've set up round robin studies. But there's no time like the present to start collecting data, because it takes a large amount to really truly understand how mixtures are performing in your state with those particular specifications and standards that are employed.
And I think I may use the term earlier, like establishing a baseline of where your mixes are. And I would tell other states to or advise that don't be afraid to raise that bar. I know that's something that one of our districts in particular has presented data kind of showing where their contractors' mixes were prior to implementation, and then during that phase in, the shadow year, and then after implementation, and really you may see results when you do look at the performance that you're seeing. Also look at the potential for raising that bar and getting improved performance. We feel like, and we're starting to get that kind of feedback, and this is our 3rd season of full implementation, right, Brian? I think. And so we're now, and we had a meeting with our industry representatives a few weeks ago and just kind of talking through the different situations. You get out in the field, you get on projects, the sample fails, you retest, it fails again. What do how do you handle that, and what do you do? And that was a concern early on, I think, where they say, okay, we're trying to shoot between these two performance goals, rutting and cracking, but what if that's so narrow that you're constantly getting failing results on one side or the other, or bouncing back and forth between them? So is there really room there? So that's really, I think, is the balance that you want to try to find, is getting the best performance you can on both sides of the equation, but still leave enough room in the middle to for variability. And we do feel like we're getting that kind of feedback so far, that the vast majority of our samples are passing. The contractors have figured this out. They figured out how to design their mixes, operate their plant, and use the recycled material in a way that they can, pass our tests and be successful.
Are there any resources that Illinois DOT has that we can share as links?
The ICT research reports, the Federal Highway sponsored report from University of Nevada, Reno. There's going to be, for the regional peer exchange, I don't think that's published yet, but there'll be a report coming out from that one. But yeah, definitely we can get some links to you.
We'll put links on our website under this episode. And if you want to get in touch with Illinois DOT about what they've done, we will put some kind of information about that on the website as well. So Brian and Brian, thank you so much for your time today. And thanks again for sharing all this information.
Thanks for having us.
Thank you.
Thanks for listening to AASHTO Resource Q&A. If you'd like to be a guest or just submit a question, send us an email at podcast@ashtoresource.org or call Brian at 240-436-4820. For other news and related content, check out AASHTO Resource's social media accounts or go to ashtoresource.org.